So in this video, we will be discussing about the logic gates in computers. This is also one of the important topics because they would give you some gates like this, and they would ask like what would be the output of these gates. So if you don't know the basics about these gates, you would not be able to solve those questions. So let's discuss in brief about the logic gates in computers. So there are basically 5 6 gates in computers. Let's discuss one, like what these logic gates are basically used for. So like for example, you have to do any arithmetic operation, or you have to store data, or you have to control any process. These logic gates are used. So let's quickly discuss about the gates. So the main basic gates we have in computers are AND, OR, and NOT, and other gates are derived from these three gates. So first one is the AND gate. So what does the AND gate do? Firstly, understand this symbol is a AND gate. It's kind of like a D. So if you see anywhere this kind of symbol, it's a AND gate. It takes two inputs and it has one output. What does it do is it gives the result as 1 when all the inputs are 1. So here 1 you can say true, 0 as false, or you can say 1 as on and 0 as off. So if the inputs are 1 and 1, then only this gates give 1 as output. You can also consider, like, just there's a tip, like if you, for the AND, you can consider as a dot, and dot in maths is multiply, right? So assume is like if I multiply 1 by 1, it gets 1. If I multiply 1 with 0, it gives 0. If I multiply 0 by 0, it gives 0. So this is just for understanding, but it's not true like this is a multiplication or anything. Don't think as it. It's just a trick to learn, which I followed. I'm telling you. So if these inputs, like suppose this input is A and this is B, the output would be A dot B, and this value depends on what you are giving as input. So you can consider like input 1 is A and input 2 is B, and if A is 0 and B is 0, the output would be 0. So this is what AND gate is about. If both are 1, the output would be 1, else the output would be 0. This is the truth table for the AND gate. So truth table is important for the logical gates. It's not asked in like you have to write the truth table of the AND gate. It's just for your for your knowledge they have created. If both the inputs are 1, the output would be 1. The next gate is OR gate. What does the OR gate do? So this is the symbol of the OR gate, kind of a D, but it's here curved. It has a curved on this side, and this is OR gate. You, just for a trick, can consider the OR gate with a plus sign. So if both the inputs are 0, then the output is 0, else in every case the output would be 1. If all the inputs are 0, the output would be 0. So if I plus 0 plus 0, it comes 0. If I plus 0 plus 1, it will come 1. 1 plus 0, 1, and 1 plus 1 is 1. This is not true for the Boolean algebra. Don't get confused this with Boolean algebra, because in that it comes to 0 and we carry 1. This is for the logical gates only. So if you have OR gate and if all the inputs are 0, the output would be 0. This is the symbol. This is all you have to remember. This is the truth table. This is what we have here. This is the same. Then the NOT gate. So this is the third basic gates in the logical gate in computers. What does it do is if the input is 0, it will give the output as 1. If the input is 1, it will give the output as 0. So it does complement the inputs. So if, like, suppose I say that input is A, it will make it A complement. If it's B, it will make it B complement. However, this is not the case. Here it's given two, we can say 2 inputs. It can also be taken like this. This is the basic, like if I give the input A, it will return me A complement. So if the value of A is 1, it will give 0 as output. If the value of a is 0, it will give the output as 1. So this is the NOT gate and this is the symbol. You have to just remember these things. Now next comes the NAND gate. NAND gate is basically the combination of AND gate and NOT gate, and its symbol is like this. So if you remember, this is the symbol of AND gate, and on your NOT gate you have this small circle which they have is added here in the NAND gate. So this is the symbol of the NAND gate. Let's see its truth table. So the NAND gate is the inverse of the AND gate, and its output is only 0 only when all its inputs are 1. So if this is 1, if this is 1, it will give the output as 0. You can see here. So how it is done? Let's say I passed 1 and 1 through AND gate. Okay. So if you pass 1 and 1 through AND gate, the output is 0. So for the NAND gate, we have NOT gate after the AND gate. So output was 1, it complements it, it came to 0. So this is what is telling that if both the inputs are 1, the output would be 0. So if you don't remember like what is the truth table for the NAND gate, you can just remember just of the AND gate and just complement all the inputs, all the columns of the truth table of the AND gate. So this is the output, or you can say this is what we get if we pass values through NAND gate. Let's see for the NOR gate. So NOR gate is a combination of OR gate and NOT gate. So it will also give just a complement of all the OR gates. So if we say, okay, this is the symbol of the NOR gate, you have to remember this. Don't get confused by this. This is the OR gate and this is the NOR gate. So let's see for the OR gate. So if we see the OR gate, if both the inputs are 1, it gives 1. If both the inputs are 0, it gives 0. What NOR gate will give is the complement of those. So if both the inputs are 0, the output would be 1. If both the inputs or either of both the inputs are 1, the output would be 0. This is all you have to remember. Another comes is the XOR gate, which is exclusive OR gate. So the XOR gate gives output 1 if exactly one of the inputs is 1. So listen this carefully. If exactly one of the input is 1. So if you see, so here none of the input is 1, the output is 0. If we see here 0 and 1, exactly one input is 1, the output is 1. In this case also exactly one input is 1, the output is 1. If we see this case, here both the inputs are 1, the output would be 0. So you have to remember that exactly one of the input should be 1 for the XOR gate, and then the output is 1, else it's 0. Then we have XNOR gate, which is exclusive NOR gate. In this, it's the inverse of the XOR gate. So what does the XOR gate say? That exactly one of the input should be 1. Here it inputs 1 if both the inputs are same, either both 0 or both 1. There it says that exactly one input should be 1. What here it says that if both the inputs are same, if both the inputs are same, then the output is 1, else the output is 0. There it was talking about exactly 1, here it's talking about both the inputs. Both the inputs should be same, the output will be 1, else 0. This is the XNOR symbol, XNOR gate symbol, and this is the truth table. We have one more logical gate, which is basically the combination of all the logic gates. So what we say, like suppose I can create one logical circuit with all the gates. Like I can say that this is your NAND gate. It gives these inputs. I created this logical circuit, and then again I passed that input through one NOR gate. And then I can ask you like what would be the output of this particular logic gate, and this is what exactly asked in your NIMCET exam. So the inputs can be AB or AB complement. Like now you have to find, first you will find the what would be the output from this gate, what would be the output from this gate. Those output would be the input for this NOR gate. Okay, then here comes one more boolean expression, that would be your answer. So there's a one you can say example of a combination of logic gates, which is a half adder. So what does it do? That it's a circuit that adds two binary digits A and B and outputs a sum of S and a carry C. It is built using an XOR gate for the sum and AND gate for the NOR gate. It's not so much important, it's just you need to know about it, what is a half adder, and this is the truth table for the half adder. Till now you have to just remember these basic gates so that you can solve your paper.